Okay, everyone, today we're going to be talking with Alex. I forgot his actual name, his nickname, but he's going to remind me as soon as he jumps on. So let's get Alex to join. We're going to talk about robotics and animation, but in real life, not the dance. We're going to talk about the dance, but we're also going to talk about robotics and how you can apply that real knowledge into the dance. Because you see, a lot of us are dancers that are imitating robots and animation, but we don't have, I don't think, a lot of people that are animators and actual roboters taking from that and bringing it into the dance. So we're going to talk with Alex. Alex, can you hear me?
Hey, yeah. Hey, Jay, how you doing, man?
Good, good. I just got out of work and I'm excited to talk, or at least talk again, because we
Right.
had our own discussion. Um, First of all, Alex, do you go by Alex or do you go by prototype? Is it?
Yeah, either's fine.
Either.
I'm not picky. It's all good.
So, yeah, prototype. I'm not sure how we ended up getting in contact. I know you are from currently in Chicago, correct?
Yeah.
Correct. And I know that you also have an animation event as well going on over there.
Yeah. We're throwing our first animation battle, Devils in the Details, in September.
Okay, okay. And I know you were also at Unimate as
Yeah.
well.
Yeah, that's where we got a couple rounds in, and I was like, hey, this
That
kind
is
of
what
you're
that
still,
was
yeah, well,
got.
yeah,
Okay, okay. So then I know then we started talking on Instagram, and there was an interesting, and this is what we're going to get into for everyone. There was an interesting comment, or you shared with me just about how the practical knowledge in robotics, machines, toys, the practical knowledge in actual stop motion animations, cartoonists, like how we could look at that or kind of educate ourselves in the actual knowledge and bring it into the dance. And you have actual background experience, a career related to machines, toys, and animations, correct?
yeah, yeah. So functionally, professionally, I'm a toy inventor. Which is we call it design engineering. So it's we come up with a toy idea, we build prototypes, and we'll create like licensable technologies. So a lot of what we do is like robot pets, animated like plush, like Tickle Me Elmos and things like that. So they're some of the jankiest, like cheapest robots you can build, but they're very toyetic. They have a lot of it's about the character and the quality of the movement being like animated, right? Like looking like cartoons or looking like characters. And so we think a lot about the qualities which things move and how we can accomplish them in robotic ways. So I've been very lucky to have a lot of insight into kind of like a very ground level, like surface accessible robot, like a technical background. And then through that, I also know a couple like professional animators, like 2D animation and stop motion animation, and I've taken some classes from them in understanding how those processes work. And I think by digging deeper into the actual source material, we can kind of open up new avenues of exploration in terms of how we approach character and approach animation in our execution, right?
Yes, yes. And I know we had a set of questions. I totally don't remember the questions we had when I messaged you initially, but we're gonna freestyle it.
Sure, that's fine.
We'll freestyle it.
Yeah.
So just so everyone here is clarifying, would you say you understand why certain materials affect the movement of the machines and why certain gears, how the movement is actually working? You understand that,
Yeah. So
would
my expertise is in like the hardware to software like design side. So I'm not a programmer, but I work with programmers and I'm on the engineering side of creating like gear trains and lever systems and linkages and like cam systems that drive robots. Usually there it's one motor that drives a bunch of different movements on like timers. in order to because toys have to be cheap. So but it's good because like a lot of fancier robots nowadays will use multiple motors to get like complex movements, and then they it's mostly a function of programming, right? But because what I do is so mechanical, you get to see all the mechanical like glitches and failures and like behaviors that we use a lot in dance, right?
Hmm. So here's a question I have then. Since you understand, let's say you said the gears. What was the term you used? The gears?
Gear train.
Gear train. Can you, and you said there's different gear trains depending on like an older robot or like the newer ones, correct?
Right. Yeah.
Okay. So with that knowledge, because again, I wouldn't know that unless I looked into knowledge of robotics and actually seeing it. Can you display or show me what do you mean? Can you show me with movement what do you mean by the gears being different depending on it?
Right. So a
Yeah.
lot of this it can boil down to cost, right? Like if a robot is more expensive, it's going to have more electronic components, more like motors, right? So for example, say we have a fancier, newer robot, right? You can have like one motor in the neck and then one motor in the arm, and they're independently driven, right? So if you right, you get like this.
Oh, you okay, they can move separate. Okay, I see.
Right. So
Independent.
these are independently driven motors, right? Whereas if you have one and they're linked, and one of them gets like stuck, they both get stuck, right? So
Mm.
I'm just thinking about like when we see really powerful robots like technically dancing, right? Uh, when,
Let me
um,
it's loud out there. Okay.
but
You were
right,
saying.
so like the idea of like what movements you choose to link and not to link, right? And sometimes two movements says so two motors, right? And these look linked, but then if this one gets stuck, right, this can keep moving, right?
Yes.
Whereas like if they're linked by a gear train, then they're going to get stuck and like glitch out in the same place. And so just like
Interesting.
of that and mechanical failings and specifically like the use of bounces and shakes and how we can like apply those kind of textures to represent like mechanical failings is something that I've been looking really heavily into.
Wow, wow. Yeah, so this is great because I see this as, as a as dancing, as a dancer watching a robot, I may go, "Oh, cool, a robot, they have patience, they move slow, they have stops, isolations." And then I could kind of go creatively, okay, maybe a robot will kind of glitch like this. I have an idea of what glitches are. Oh, I know robots like I have a general idea, but you're saying because understanding the different gear systems, you don't really have to go that far with coming up with ideas and kind of trying to figure out, oh, I want to create a different. You're like, no, just look at the material already.
Yeah, I think so. One thing that I'm really passionate about is just the source material and the research we do on like what we're representing because like the OGs, right, whenever you talk to the OGs about where this dance comes from, it's always reference driven, right? They're always talking about like this cartoon character, this movie, this new special effect that happened, right? The That's like on the animation side, right? Like claymation and puppetry. Even like the basic robot that we all learn at the start is mannequin, and it comes from mannequins, right?
Mm,
Like so reference has always been a huge part of animation. And you can kind of look at animation as a dance culture, kind of the way like it's almost similar to hip hop in the idea that every year in hip hop there's like a new party dance that gets really popular, right? And once it stops being like a party dance, like a fad party dance, it becomes part of like the hip hop lexicon, right? You know,
mm,
like there are
yes,
new moves that come out of like the party dance scene and social dances that then move into hip hop, and you can kind of say the same thing about animation that there's new like special effects and new animations that come out that influence things, right? Like I mean, a really obvious one being like The Matrix and the
yes,
idea of slow, like it didn't create the idea of slow mo, yeah, but it
right,
definitely like helped like it made it more popular in the moment, right? People were like, oh, that's cool, Terminator, right? There's a whole robot style around the Terminator, you know,
yes.
and
So you're
so,
saying reference to reference. Okay,
yes.
well.
Yeah, so as we move through through time, new references and new sources materials crop up, and like our OGs were masters of observational learning and looking at robots and machines and animations and reflecting them, and that in this it's like in the spirit of animation to for us to do the same, right?
Hmm.
Um, I think we look really really hard at our OGs for like their techniques and their movements and their characters, which is good. Everyone should do that, obviously. But then also you look at it as okay, so like with these techniques and these applications, what's like a new look or character that I can be inspired by, right?
Yes,
Yeah.
nice. No, and it's refreshing. It's like a new path you can take to increase your own what's possible you could do with your style, your character. We're talking about robot animation right now, so that's a really great just a guidance, an approach to let me study an actual machine toy and understand it. Versus which of course, like you said, it's great. Learn from the OGs, understand what they were looking at. That's awesome. But also find something like because when they started, there wasn't someone they were watching from my in the sense that they didn't see another dancer. They may have, but it sounds like they didn't see another dancer doing the robot and then wanted to imitate them. They were looking at an actual robot and was like, I want to bring that into the dance.
Hmm. Yeah.
Would you say?
Yeah, I think
Okay.
that's I think like whenever I hear, like any pretty much any OG talk about what they're the way they're dancing and the way they're executing, it's always reference from some type of robot, some type of character, and that's like that's persistent, right? Like Dre with his like
Oh
kind
man,
of like what do we call it, like animatronics, right?
yeah.
Robot Prince tends to have like a heavier bot, right? Like a lot of more bounces and like they may not give a specific name to what they're doing, like the or maybe they do some of them, right? Like I've seen people say like this is my like this type robot, right?
I
Um,
think what I've started to interject. I think what I've seen is people call themselves a character. They would say, I'm dinosauring. I'm when they
right,
say Sinbadding, I'm the movie. That's the name of the movie. I'm gonna call it the movie that I'm doing.
right,
So
yeah,
okay.
even like the technique is named after the movie. Yeah, it's
Hmm.
yeah, it's just kind of like there's replication of like the dance as they do it in the sense like taking the exact characters and the exact like techniques, but then there's like looking at the process that our OGs used to get there and to create these styles and think like how can I try to do that as well? Like, look at like new animations and stuff and new like one thing I've taken a lot of inspiration from, for example, is like you look at like Into the Spider-Verse and like the way those movies are animated out. And I really like the moments where like they're moving through space and then when they're in the wrong dimension, they like right
Yes,
all
yes.
out. Right, that kind of like that's a animation I've not seen before. The idea that like they're cutting between multiple worlds that have like all have different like textures and behaviors. You know?
Now, would you say you understand the actual how they did that effect?
Yeah, yeah. They and so like they functionally they animated that character in like a couple dozen different styles and then just flipped through it, right? So they're changing
Mm,
the characters like shape, form, like texture, quality, and they just like stagger through
ooh,
it really, really quick.
interesting.
Yeah,
Okay.
so yeah, it kind of reflects like almost like the fast forwarding effect, right?
Hmm.
Yeah.
Okay. Like a flip book, are you saying? Well, no, the fast
I
forwarding effect.
mean, sure. Yeah, I
Okay.
mean, but it's just drastic changes in like dimension and timing really, really fast, right? Like, right? Like,
Right.
that's kind of, yeah.
Okay. So then my question, before we go to animation, because robot and animation are separate
Mhm.
for everyone as well listening. Um, can you share how have you used your knowledge, understanding of machines and toys with your dance?
Yeah,
Could you
absolutely.
share? Yes.
So one thing that I think a lot about in terms of robotics and specifically is like how expensive your robot is and how that influences the material it's made of, and the types of failures you get and the types of behaviors you get, right? Like so for example, like really really tight, like high level robotics, like the fancy stuff, they're usually they're usually like driven by really really precise servos, and that's where you see like the chibi robot, right? Just that perfect ding 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 ding, right? It's like flawless, you know.
Yeah, would you say like chibi robot Val clocks? Would you say
Yeah,
they are
that range Martin o'clock, Mick.
Mark clock?
Yeah.
Mick? Okay, so and you're saying that it's an advanced robot, and how can you explain again the pieces?
So like we talk about like the a perfect robot, like the perfect technique is kind of wasteless, right? So your dime stops, you like move perfect switches, right?
Hmm.
Move, switch, switch, switch. There's no waste in like a perfect robotic technique.
Right.
Um, and that is usually driven by really really like high level like computing. So that's like expensive is the actual like electronics that are driving the thing, right? They
Mhm.
need a lot of capacity and to be really like fine tuned. You get better like for position recognition, like the potentiometer that it's rotating and it knows the position is a potentiometer being like a motor that has like a little arm coming off of it, and then there's an array of magnets that
Ooh.
around the potentiometer. So when it knows it's at magnet one, magnet two, magnet three, magnet four, magnet five, right? Really, really fancy ones will have like 360, like really nice. They'll know like slight positional differences, right? Uh,
Mm.
toy grade
Wow.
ones I work with can be way worse. Like you have like 30, and it's kind of like like the interval, like instead of being like one, two, three, four, five, it's one, two, three, four, five, right? So
Oh, it's like jumping.
yeah, the resolution's literally lower, you know? And so you can see that in the tuning of things and behaviors where like if you know what like about like anything about calculus, right? The idea of like a curve like
Not really.
all
I
right,
hated
so
that.
like in calculus, a curve like this, right?
Okay.
How you measure, how you calculate that out is by like the area under it is by estimating a number of rectangles underneath it. So it'd be
Hmm.
like the area of this rectangle, then this rectangle, then this rectangle,
Okay.
and it kind of averages to this, right?
All right.
Or the more rectangles you have, the closer you get to a true measurement, right? The smaller those rectangles are, so if you think about
Okay.
like you have like a 3D printer, you have an X and a Y axis, and they're arms
Yes.
that this thing moves on. This what it's actually
Yes.
doing is moving from like number points. So you can take this movement, this curve like this, and you can break it up into like this. It's actually doing like slight X and Y movements to
Hmm.
to travel that distance, right? And if you like change the averaging, then it gets like less
Oh.
lower and lower resolution, right?
Interesting. I like how it's also interesting how you're saying lower resolution to describe the qual. I mean, again, I'm not aware of this field, so to hear lower resolution, it describes the robot as more lower, not as futuristic, more mediocre in a sense, more simple, more quality of less expensive.
Yeah, it's janky, right? It's like
Thank
yeah, it
yes.
has like slack, and that's another thing is like the materials that they're made of and where their stability comes from. So like every material has a natural elasticity, right? So like I've got Mickey over here, right? Like if we look
Hey.
at him like this is a robot, right? Like in the way you see that?
Okay.
Like
Yeah.
so that's he's stabilized by springs and he has like plastic limbs that have a lot of joints in them, right? So there's
Okay.
tons of slack in his behavior, right? So if you're doing a robot that is cheaper like that, you're gonna get a lot more like tremors, right? Because it's stabilized by springs. So when it like you think about like this, if there's a spring that's running from here to the back of my hand, right? So it's anchored up here in the corner, and
It's
you
like a
pull away
spiral. Is it like a spring? Is it a spiral spring or does it matter? Or
like a
okay,
spiral. So
okay.
like you pull away from it, and tension builds, and then shing,
Oh, okay.
and
Yes.
this arm is made of metal, then you're going to get a lot less like
When?
bounce.
Okay.
Like plastic has a lot more flexibility than metal, right? So like there's not like material elasticity at play, and then the elasticity of so the springs themselves. Like a lot of people don't know the difference between bounces and shakes, for example, right?
Ooh,
Like
whoa, hold on, hold on. Bounces and shakes.
yeah,
That word is used interchangeably to describe this stop effect, like this
right.
sudden. Okay, can you explain the bounce
Okay,
and a
so
shake?
yeah, so a bounce is against a surface, right? So if there's a plane here, it goes bounce, 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 right? And you can do that. Like that's the thing. Like springs emulate gravity in different directions. So with a spring, you can have a bounce where there's a wall here, and you go bounce, 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 bounce.
Oh yeah, like a pull
Yeah,
back,
exactly. So that's
pull
that's a
back.
bounce. People tend to use bounces in terms of like gravity, which is true, but you can also like that's a bounce, right? Because it's hitting a wall. But
Okay,
shake, a shake is if you have a spring on each side that are running out off to they're equal springs that pull it like this. So it's in tension, right? And when you pull it this way, this spring gets weaker, but this spring gets stronger. So there's no
right,
wall. So a shake
right.
is shake, shake, shake.
It's going back to the center.
So a shake has woo, 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 whereas a bounce hits.
Boom, boom, boom. It
Yeah.
keeps going past the wall. The shake goes past the wall in a sense.
So like, and that's like a thing. Like, say you have your robot, you're moving. Like this is like your clean robot, and then one of the springs breaks, and you get
Yes,
because what you right they're in tension, they're fighting each other, and
yes,
then it turns from a centered sprung into right. So this is it's like shake, 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 bounce.
yes. You said the string was cut.
Yeah, yeah, like a spring, yeah, spring failure that
Oh, the
happens.
spring, the spring. Oh, wait, wait. Show me then. What would be? Show me the bounce. What would create a bounce then? Do the same thing you did if you can,
Yeah,
but show now bounce and explain. Wow. Yes,
yeah. So like if these two things are sprung together, right?
yes,
That right. There's a spring here and a spring here. They're keeping this in.
yes.
So as soon as you snap one, clip one, right, you're gonna get
Oh, it pulls it.
yeah.
It
Because
pulls it back,
this one they're not evening each other out. So and
and then
then
it bounces.
up to an extreme hits something and bounces.
Boom, 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 boom. Okay, okay. And then the shake, it can go past.
Mm-hmm.
Got it.
Yeah.
Nice. Okay. What would you call these?
Um,
What we're talking about. What would you call this?
I would call these like mechanical interactions or mechanical failures. Um, a lot of it is tied to just like when you get down to really ground level robotics, really, really like utilitarian stuff that isn't necessarily for like presentation, right? Or stuff that is like cost,
Oh,
right? Like again, like all like the idea that everything has a material quality that has rebound, right? This
yes.
like you get that spring, and then if you choke up on this, it's smaller, right?
What is creating that?
Well,
Why is it getting smaller?
so that's tensile strength. That's elasticity, right? So the longer something is, this is called a cantilever. It's floating, right? So this is a material supporting itself off its own like rigidity, its own elasticity. So the more of it there is, the more slack it has, and the
Wow.
it demonstrates its own elasticity. Every material has this, right? In different qualities. You grab a tree branch and it like bends,
Yes.
and so like yeah, like even just reflecting like this, like what material is your robot made of? Right?
Mm,
You know,
okay.
something that's plastic is going to be a lot more. It's going to have a lot more like uh, right. It may not be as plastic is really rigid, but it's like flimsier, right? It's going to have less pop to it. But it's going to look cheaper basically, right?
Right. Right.
As like something like this, like I mean, this is like almost like Looney Tunes, right? In terms of
Mm.
quality.
Yes, you said Looney Tune?
Yeah, yeah. It almost has cartoony quality in its nature. But
Yes.
yeah, I just think that like a lot of the robot we see and what's generally accepted in terms of like what's high quality robotics is perfect even mannequin stuff, which is it's dope. Like yeah, I'm not saying people shouldn't do that, but I'm saying that like you can there's so much space in robotics to add different ideas. Like even the idea of like speed changing, right? Like I think a lot of people are taught very early on that robot patience and evenness
Yes.
and to be very very even, and that's like again good foundation, right? But you can be even but change pace, right? So if the drill is like drawing a square and getting something perfect,
Yeah.
right, you can do the same drill but small fast,
Oh, that's nice.
and that's representative of just a speed change,
Yes.
right? But that's a very mechanical thing. Like I have a 3D printer out in the living room, and it the way it behaves is like it like 3D printers or hot glue guns we've tricked into building things. They're really stupid. They seem really futuristic, but they're really dumb machines. And so if you have a hot glue gun and you hold it down and you move it slow, it's going to leave a thicker line.
Right.
But if you move it really quick, it's not going to leave anything behind because it's so 3D printers usually like they literally use the speed at which they extrude material to control the thickness of what they're laying down. So like, if you're building a part here and part here, right? It'll go slow to lay down a circle, and then once it finishes that circle,
Oh, yes.
right?
Yeah.
So it's like you're pressing this thing down and go like move it to
Right,
yeah,
so it doesn't drip.
exactly. So they're just like simple things in like really a 3D printer is a really simple machine. Like and but there's so much you can watch out of it and the way it like calibrates and like uses like it like uses vibrations to check how much it's going to make the whole machine like wobble
Wow, okay.
off that. There's really cool, simple like mechanics you see, but they can just be surprisingly violent, surprisingly like jerky, and have like, qualities that are really like you wouldn't expect from a robot, right?
Right.
Given about robotics as a dance style.
Right. A question I was just thinking of, so people tend to want to get the nicest, sudden, cleanest stop, right?
Right,
What you were saying, the kind of like the level right now, or what is viewed upon is like this advanced robot.
right.
Um, how does a machine actually, you were talking about the 3D printer, how does it actually stop so suddenly? What makes it stop so suddenly?
So there's a couple things to this. Uh, so okay, so robots, you know, I mean, it's interesting even in the way the baseline techniques that we use to do the robot, right? Like
Yes.
you're flexing, your arm to hold tension, and then
Hmm.
that creates evenness, right? So what's happening there is you are tricking your muscles into working the same way a motor does. So humans move in curves, right? So fun fact, like when you're holding tension in this arm, what's really important about this and where the actual robotic effect comes from is the fact that flexing that muscle flexes your bicep and your tricep because your brain is sending an action potential down through your arm to activate that muscle, and those electrons can't go through into your arm without going through your bicep and tricep. So
Okay.
you're preloading your muscles with electrons, so that when it's time to move, there's already tension, and you're picking off at speed and moving at speed. And a motor works the same way. A motor has a switch that is closed off, right? So it's not moving. And then as soon as you flip that switch, a wall of electrons are waiting, and they hit it, and it does what Robot Mick would call an asymptotal jerk. It's not moving at any speed, and all of a sudden it's moving at the speed that it wants to spin at. It accelerates like nearly instantaneously. So that's where you get the kick, and then when it stops, it just closes off, right? With humans, there's a gradient of like some electrons, tons of electrons, less electrons, no electrons. With
Yes.
with a motor, all at once, nothing at all.
Ah, I
At
see.
all. It's a flat closure. right? Click clack.
Right.
Yeah.
Okay.
So that's why the robotic technique of holding tension works for us because you are tricking your body into behaving the way a motor does.
So then tension helps with the stop.
Right.
All right. I think that
Yeah.
was something that people, some I feel I've heard, is there tension? Is there not tension? Different views on it. But it's
There's levels to that, right? Like once you get finer controls, you can do it with less tension, but you're always going to need some.
something to activate and to stop
Right.
it. Hmm.
Yeah. But
Okay.
then so that's like the electronic like motorized element of the robot, right? But then where you get into glitches and effects that are more physical
Hmm.
are like at the end of those gear train, right? Like once you introduce mechanical elements between here and here, between the motor and what's moving, usually you need like springs to like return movements, right?
Hmm.
And that's where those failings or those like things running into things happen,
Hmm.
right? That's where gears run in like when if you have a gear train, gear, and the motor's spinning, and there's an obstruction. So you have this thing that's moving like this, right, back and forth, and you put something here that blocks it.
Yeah.
That stress goes back through the whole gear train, and the motor is just going to keep spinning. It doesn't know, it doesn't care, right? And
Okay.
what finds the weak link, it finds the two gears that have like the weakest engagement, the worst engagement, or maybe the worst centers, and it'll pry them like it'll make them go like this. They're like this. It'll make them one wrench and go like this.
Ooh. Oh.
That's like right, like ideas of like
Right. Right.
because this happening is the gears go work and fighting to try to find some slack in the mechanism to fail.
Yes. Wow. Okay. Wow. That's it. It's again. It's just fascinating because you instead of one just trying to imagine, okay, what does a glitch look like? Okay, I understand robots. I've seen maybe some movies. I've seen some cartoon. It kind of like shakes, but to understand what literally is happening really solidifies the idea for you to implement it. Would you say
Yeah,
it really implement like you're like I have direction of how I want to really create this illusion
right.
with dance. Um,
I see distortion saying some stuff. Yeah, like
Yes. Question: do you think it would be difficult for the average viewer who is often not fully initiated into the deeper mechanics, like the ones you're discussing, will be able to connect the dots? And something like a spring breaking was the cause and effect for a change that led to a different limitations of movement or different effect as a result of that malfunction would be able to grasp. Okay, so what do you think about
why we're talking, right? Is that like probably not, but like, but again, like there's a difference between what I'm trying to provide, for example, is not like you
it?
got
Not a. Mhm.
robot on robotics. It's more so like there are all these techniques that achieve effects that look cool, but people don't necessarily know why they're implementing them, right? So like why am I like using these glitches, right? And it can help with the internal narrative where even if you're not like fully baked in terms of knowing exactly like this gear's here and this gear's here and this relationship, just the idea that like I'm moving and then like this mechanical failure is happening and like also maybe digging deeper and looking for reference. There's this guy on YouTube. I can post a link. Oh, sorry, hold on. Um, it's his YouTube channel is like Thang Thang. He's from Vietnam. He's an engineer, and a series of numbers. But what he does is he 3D models mechanisms, and then he like animates them. Like he animates them to show how they work. So you can see like how like a desk that like adjusts its height automatically. You can see the inner workings of how that object works. So it's kind of it's cool, right? There's a whole world of people out there who are demonstrating mechanisms. And here, one second, I'll pull up on YouTube. I have a playlist that I
And, and while you're pulling that up, I think also distortion the message intention of the interview with Alex, I think, is to advocate for people to learn a little bit about. You don't have to know all the stuff and all the technical, but just go into the field and learn some stuff. Go YouTube it.
And just a little background on like why this matters. So, like, I got into toys. Cincinnati has a weird link to toys and like entertainment. There are a couple of companies in Cincinnati that make animatrons, for like theme parks. One of them being like a company called Life Formations, and so in all these like grocery stores and like parks around Cincinnati, there are these animatronics around that you can, there's a grocery store called Jungle Gym that's filled with old animatrons, and they're all weird and janky. They're not really like the star players, so they're kind of these weird, chunky. They move like the horribly, right? You'd expect like these like perfect movements, but these are the bad robots. These are the ones that fail. But I love them because they're just so full of like texture and character, you know?
And wouldn't you say you would like? I think we when we were talking, you were sharing about it would be nice to see bad robots actually in dance
Yeah, yeah,
or
definitely. I
broken.
think the jankiness and the kind of like bounces and shakes and all the mechanical failings and these like kind of cause and effect behaviors can really be what are really exciting about the robot. And like there are a lot of dancers like out of the Bay who were animating very early on whose characters were really heavy and were really like it wasn't that crispy, clean robot we think of now. It's got a lot of jank and they're really rigid and hold a lot of tension and play with like a lot like high texture stuff. Hey
Mm-hmm.
Rishi, but yeah, like stuff like that. Like I mean Rishi showed me like Dancer 64 and I was like enthralled. I was like that's incredible. Like what he does is just so like it's I mean it's technically strutting, but it's animated
Yeah.
and it's heavy. It's a heavy type of robot.
Yes.
You
Did
know?
you? There was a video you were looking up, correct?
Oh yeah, here. So like this guy
So
creates
that
these.
he animated that.
Yeah, so that's a motor. So as these two gears spin here, it's moving a rack. So that's like a straight gear that's turning this gear here. That's creating this like tail swing idea. And so he zooms in, so you can see where the actual like behaviors happening, right? And
Yeah.
there are dozens of these. This is S craft, right? And just how you can like drive different oscillating movements off of
I,
one motor.
if you could lower the bring the video down a little more, I think I could only see half of the screen.
Oh, I see. There, one
Yeah,
second.
yeah,
Yeah.
yeah. They're awesome. There we go. There we go.
All right.
What the? Okay. Oh, is this on YouTube?
Yeah. This is S dot craft on
So you
YouTube.
type in s.craft and you find all this.
Yeah, this is his channel. Or
Oh,
there,
this is some gold material.
yeah, but these are there's and he has hundreds and hundreds of animated mechanisms. Just
Oh, that's wonderful. That's
like
great.
that's crazy. This like planetary thing that's happening is super cool.
Wow.
You know?
Ooh, okay. Oh
So this has,
man.
yeah, right.
Oh man. Okay,
You know what I
great.
mean? There's a
Yeah.
whole world of like mechanisms that are like any if you think about anything in the world that moves mechanically, it has a custom set of internals that is designed to accomplish a very specific task, right? And each of those characters, each of those like machines and behaviors could be a whole robot character. Like, look at this thing. What the hell is this? I don't even understand what the point of this is, but that's crazy, right?
Wow. Well, let's see. Hold on. Hold on. I want to see. I want to watch that one.
Yeah, I don't really understand.
Wait. Is that's real?
Yeah, that's in real life.
Oh, I thought it was like a 3D animation.
No, that's a real
So
someone built that.
it's like this interesting the the way it pulls, the way it like oh wow, he sped it up.
Yeah, and you see like the violence and the bouncing.
Yes,
Like,
yes. Oh,
yeah,
like this one. It goes. There's
yeah,
like a.
sure.
Whoa, I see. Wow. Okay. Interesting.
Yeah, so there's just, and so like that's crazy. The zoom.
That spin in the middle, right? Like how to replicate that with the body.
What is that?
That one looks very cool. Wobble. Whoa, that's a very. It's like a wobbling or something.
Yeah. So right, and so like yeah, like a lot of this stuff is like there's a dance relationship here, right?
Yes, the arm. Like you could imagine. Huh. Interesting.
Right. So yeah, there's so many there's just so much like application potential. I see so many strange machines that get built, for like really niche reasons. And I just think, man, that'd be such a cool, like, you could spend a lifetime just taking that one mechanism and just applying it to different movements in your body and creating
Yeah.
different relationships, you
Yeah.
know?
What would you like to from what would you like the robot community to know, or what would you say your message is for like the robot community specifically?
Yeah. I think that, like, I guess, like, as we I know there's a lot of discussions around defining the styles and what they are, and what type of movement they hold.
Hmm.
And I think that, like, there's a robot that is currently, like, it's considered the ideal, right? And it's that perfect mannequin, super clean, super even, like high detail. And I
Hmm.
understand why. It scratches a certain itch in your brain. It's like a
Yeah,
visual
nice.
cliff.
Yeah,
I trained that, like, that is the base, right? That is
yeah.
the base for robotics, is being able to hit that visual cliff, like, surreal area. But
Hmm.
I think that there's a lot of it's more I'm just excited about it. Like, there's so much untapped space for
Hmm.
the robot, right? There's so much unrealized potential in the way that we characterize, robotics. And I had a really interesting conversation with Affliction while we were on the Bridget Taco session about, like, what what reads robotic, and, like, how robots move, right? And, like, there's a perception that robots move a very specific, very narrow way, and I
Hmm.
just don't want people thinking that, like, I want to see, like, people in robotics take more creative risks, just, like, play with, like, defining your robot and looking at, like, what is what mechanisms can be,
Right.
and like the range that they have and the kind of character that they have. And yeah, like, I'm just excited to see more and more of that, right? Because there's so many new robots, like, people doing the robot.
Hmm.
And I
Yeah.
think that the idea that, like, we can't we like I don't want everyone to look the same, right? There's so many avenues for making your robot your own,
Yes.
right? So just doing your research and finding a robot that you really treasure, you think is really really, like, interesting or exciting or compelling, and just chase that down. And even if it's not the robot that everyone's, you know like, saying is, like, the right, there's no right robot. There's so many robots. There's so many machines.
Right.
Yeah.
Exactly.
Yeah.
Wow. Okay. Well, with that being said, I would like to transition into animation. So this is like that's like that was like part two. Again, you have a background. You said you worked with animators,
Mhm.
so understanding the process that goes into creating a picture or moving picture. Um, my first question is, what is animation? The million-dollar question.
So animation, in in the art form, like the non-dance form, is using consecutive frames of images to create the impression of movement and create character. Thank you, Rishi. I'll define. Um, and then in dance, this is throughout the Midwest, like, generally accepted as, like, our the definition of animation for us, is it's a character and an illusion, a time driven illusion,
Mhm.
right? And that comes to us from our, like, T Boogs. We got Pop and Chuck. We have OG Cobra, and then my personal mentor, Eclipse from Cincinnati. He has he learned a lot about street performance from Midnight. I actually talked to you about this the other day. So I thought I talked to him yesterday because I was, like, asking about where the definition of animation we use comes from. I thought it was from Midnight, and because he learned from Midnight a lot of animation. But it's actually, he's like it's not just that. He's like, it's Midnight, yes, but also conversations with Jerry Rente.
Really? He was connected. We talked with Jerry Render from One Plus One, the worm. Yeah,
Exactly.
Oakland.
Exactly. So, like, I'm like, that's I mean, that's about as close to the sources you get.
That's yep, pretty much. Yep, that's for yep, yeah, yeah.
So like the character in the illusion, and so I was like oh shit because I just watched that Boogaloo Dana interview. I was like
Yes.
so yeah like that's kind of the definition that has been going pretty well for the Midwest so far. It's a
Okay.
and an illusion, and that character can be dancing. That character can not be dancing. You can do it as a dance style, engaging with music, or or not, right? And use it as a form of like performance, like a magic trick, right?
Mm.
But that's kind of how we view it, and the like everything I've learned about animation as a art form, like the 2D, the flat version that happens like in camera, that is that has only like enforced that idea and enforced that deepened that, right, of the character and the illusion, right. um
Okay.
so a couple like my so one of my coworkers um from working in the toy industry, he's a stop motion animator,
Hmm.
and he teaches stop motion at the University Columbia College downtown. It's an art college downtown in Chicago. He
Nice.
had that work for like Leica, the people that do like Cuba and the Two Strings and
Oh,
Coraline and
okay.
stuff.
Yes, yes.
He's been doing this. He's done like he did some Hamburger Helper commercials back in the day when he was doing like a stop motion animation professionally. He
Okay.
doing it for 30 years. He knows it in and out, right?
Wow.
He teaches, and he was just telling me that there's like some of the things I've learned about the idea of uh like stop motion and the idea of like character, you know? So for example, when you learn to do animation as like a 2D art form, right? So say you're drawing, you're hand drawing animation cells. The first thing you this is like the first thing you learn how to do is to draw a ball bouncing. You learn to emulate real life gravity and real life physics, right?
Hmm.
Because those things, they occupy time, right? Like they're things that we interact with every day in our real life, and so being able to make something realistic is step one, right? So there's ball swinging, bouncing, and then you'll take that character and you will bring it to. You'll take that ball, right? And your assignment is to bring it to life via animation, because there's a lot of times in animation where you can't you're not the character's not communicating by talking, they're communicating by moving. So you need to know how to convey like a character without words or sounds or like a driving narrative. So you take this ball and it's just a ball and you turn it into a character, right? So it's like you have to make it like happy, right? So it's like ding, 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 right? Like, or you have to make it like scared, so it'll be in the corner like shaking, like slow roll and like look
Yes.
around, right?
Yes, yes.
The idea that character can come from movement quality, right? Like movement quality can inform a character. And so the idea that you have to have a character when you're in that character, it can be like, the Dinorama. It can be those classic, right? Like Cyclops, like Kali, characters. Or it could be something more abstract. It could be, a movement quality that conveys a feeling, right?
Hmm.
And it
Right.
doesn't
Like, hmm?
need to be so cut and dry, right? Because the first characters you deal with when you learn animation aren't even living things; they're just objects.
Someone, signature role character conveyance while representing the tone and feeling of what the music is trying to communicate. So this is great because I know that's been another topic of what is character in animation? Is character a part, a foundational part, or where does character play in animation? Some people say you don't have to have a character. Some people say character is part of it. And you're saying character seems to what? So I don't want to assume now. Okay,
In an animation, if you're moving, you're a character,
okay.
right? Anything that's moving, actively moving, is a character. Anything that's in the foreground, whether or not your character is particularly like interesting in its own nature, or whether you have like because there are people who like and like again, if we're talking about early things you learn in animation, one of the things you learn is a walk cycle,
Hmm.
right? Which is just drawing a character walking and it repeats.
Hmm.
right? So you can animate a walk cycle, and that's where the dance element comes in of like using the animated timings to hit beats within the music, right?
And would you say you are a character just by changing the timings?
Yeah, yeah, absolutely. Timing plays a huge role in how a character is conveyed, right? Like whether they're like like moving slow or like rushed, right? Like there's a lot of like character built into timing, you know. Um, animators like really good stop motion animators because it's such an intensive process that's so right like tricky. There are tricks that they use to actually like plan out each frame,
Okay.
right? So you'll have a storyboard, and you'll have like the character moving, right? Like each move kind of like logged. Like this move is going to take this many frames, and then this move is going to take this many frames because you have a sense of timing of when you want each character move to happen, right? So
You know what type of movements you want, you're saying.
yeah, so if you're shooting on ones, 24 frames is a second, right? So if you know you want your character to like duck, that's going to be, and you know that's going to be 6 frames because that's going to be like one quarter of a second because it's a fast movement, and then
Yes.
he up back up over the
Those are
wall
a lot more frames.
a lot more frames because you're moving slower. So you'll plan that so that you'll have a second and a half of him like, which then a second and a half in 24 frames. That's you get the idea, right? 36
Yes,
frames.
yes. More frames, less frames, the spacing
Yeah,
and the timing is conveying a feeling because we associate something going really fast with attention or like alert, something going slow. Right, the layers, the layers.
and there's elements of like math to it where it's like, for example, if you're something's bouncing, right? We talked about the bounce, right?
Mhm.
Wash and stretch of how many frames it's going to take, but like the idea that if this bounce happens and then this is half the height and then this is a quarter of the height, this is an eighth, right? Then the frame spacing, right? You can actually do the math of like, okay, this first bounce takes this many frames. I want the next one to last go half as high, so it's half as many frames, half, right?
Right,
To
right. It would be like trying to like skip, like, and then go more here.
so if you take the dance and you take the idea of like 30-second counts, 1E and a or wait, is it? I guess it's 16ths, right? 1E and a 2E and a 3E and a 4E and a 5E, right? And you make each beat a frame,
Mm.
right? So you can go like I was saying, like you can like right? It's that same duck, right? So it's like 1, 2, 3, and then less frames, right? You can
Yes.
and the idea of like even with animation, like a really simple thing with stop motion is the idea of shooting on ones or twos, or if you're like a student, threes and fours, um, and how many like shooting on ones or twos or threes or fours refers to how many frames, you, how many frames is the same image. So if you're shooting on ones, there's 24 frames per second, so each frame is different. There's 24 frames total.
Right. So it's smooth. Well,
It's much smoother, right? It's much that's where you get the really high level professional studios, right? That's like Coraline was shot on one.
okay.
And then you get into cost saving measures. So shooting on twos is half as expensive because every image is 2 frames. So there's only 12 images per second. So you're cutting it in half. So the studio has to do half as much work, but that's where you get that classic stop motion feel.
Mm.
There's like bigger gaps in the movement, and that's really classic stop motion. That's
Nice.
when we picture the stop motion effects.
Yes.
And then lesser known as 3 and 4s, and that's usually like your one man show putting this thing together.
Would it
Right.
probably be like
Yeah. So it's yeah, the spacing's a lot worse, right? Um, or each frame holds for a longer amount of time. Yeah.
mm,
But that's the thing you can apply to your dance, right? So you can be like you can like 1E and a 2E and a 3E and a 4E and a 1E and a 2E, or you can be like 1E and a 2E and a 3E and a 4E and a 1E and a 2E.
and then start
That's twos. And then you can be one two three, 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 which that'll in music that'll be an off timing. It'll look like a kind of strange, but it's still musical. And then you always have like one two three four, one or one E and a two E and a three E and a four E. That's on fours, and that starts to get into like ticking, really, right?
Right, because tick. Okay, this is interesting. The terminology as well.
Yeah. So there's like yeah, like obviously it's not that cut and dry because the frames and times at which things happen are not the same as like timing in music. If the song's slower, then it's gonna change the rate, right?
Hmm.
Whereas like frames in animation are always 20 per second.
Hmm.
But it's just a thing that's a drill you can do, right? Like take a song and break it down by layers. So can you stop on ones? Can you stop on twos? Can you stop on threes, right? Where
Yes, yes.
skipping frames does create more fast, correct? So that's an interesting thing too, because um so in stop motion, the the character is always moving and there's always 24 frames in a second, right? So what's happening is a character that's standing still is still going to have like idle animation. So you're going to end up with like this is Sinbadding, but it's small. This is Sinbadding on like a in a position, right? And then if you want the like stop motion effect to get bigger, then you put more space between each stop.
Mm.
Right? So the timing's always the same. It's always one E and a two E and a three E and a four E and a one E and a two E and a three. But then you just one E and a two E and a three E and a four E and a one E and a two, right? So you can actually hold the stop motion effects while idling in position and then bring like use it's all about the spacing. You see what I mean? You can hold a like a stop motion effect and then just change the spacing of the movement. So like where your character is not moving as fast, it's smaller. And then where you're doing faster movements, it gets bigger and then it's smaller again. That's how an animator, like a stop motion animator, would approach a character.
Man, and you know what? This is where I feel that if people there's so much rich untapped possibilities with stop motion style implementing it into the dance itself. There's so much potential that can be explored with just that. I know some may say there are, multiple types of animation, stop motion being more of the original or the OG version, and now we have, so many slow motion, NPC, all different textures. But I feel it would be so great to see back to what you're saying about the robots. Go, let's kind of not look for the perfect future, but go to the past and expand on that.
Yeah. Yeah, I think there's a lot of um like the root again, like the roots of animation are in this, right? And
Mhm.
a lot of OGs have done like everything I'm talking about is nothing new. They do this like um,
Mhm.
you'll see in like a lot of the stop motion Dino-Rama characters, the classic, Sinbadding characters when people are doing stop motion. There's like bigger movements where they like travel through it, and then there's smaller like they'll hold a position, right?
Right.
Like they'll sit in a position and just do these micro animations, and then like then the big move comes out and you move through it bigger, and then you right like this is stuff that has been done. None of this is anything necessarily new, but it's about understanding the why, and then even then, like when we start to move into like ideas of slow mo, like you're saying the newer stuff, right? Like slow mo and time control effects.
More, yeah, I would say more video playback, like more editing when it comes to like being able to,
Yeah, exactly. Yeah, yeah, like you said, that's more video editing, right?
yeah, it's more what I would say is seen more now, more of a speed control. Speed warp, or would that be called ramping, speed ramping in film or editing?
Yeah, ramping up, ramping down. Yeah,
Right. So I feel, speed ramping more of a current technology, stop motion more of the past. Both
yeah,
are this manipulation of the flow of the video. Um,
yeah.
Dang, there was something I was going to ask. I had two questions, but now I'm left with just one. Maybe the other one will come up. But the one question was, can you explain when we were talking previous, when we weren't on live, when we were talking before planning this, you talked about the music or groove or dancing, animation dancing, and about the groove versus, or if you can kind of go into that.
For sure. So, and this gets it back to like the idea that animation is a character and an illusion, and you have to have both, right?
Okay.
So there's the idea that, and like we said, a character can be abstract, it can be really concrete, it can be really classical, be something new, but there's always a character and there's always an illusion. And I think where a lot of the discourse gets confused is the idea that like, what is animation dancing versus animation as a, like performance. Um,
Yes.
and a lot of that comes to the musical connection and how you interface with the music. And I will say that part of animation dance, from what I've seen, again, this is like when you look at like again the OGs, like there's points like Gizmo, right? Like Gizmo was saying that he will practice the illusions first. Like they put the illusion and the story first, and then they do it with the music. And some like it's not nearly as important that you're on beat and hitting beats as it is that you're frying people's brains with the illusion, right? So
Yeah.
there's points in the music where you line up with it, and that it's like dance like at the front where it's like you're hitting those beats. But then there's times where you detach from the music intentionally to create performance elements,
Okay.
right?
Yes.
So but regardless, you can take a be dancing or the character cannot, right? So when you look at like certain types of movement, like certain animators in their approach, like he's Mega Man, right? He's got reality check, right? Mega Man's character is dancing, right? It's the character on screen. If you take away the layers of stop motion and animation, the
Right. There's still this dance. Right. Right. Right.
character augment and add another layer,
If
right?
you could repeat that one part, I think your sound went off. If you could just repeat that part.
Yeah, like a dancer like Mega Man, right? It's grooves, right? The character is dancing, and then he's layering animation on top to augment to enhance it, right? Whereas like a dancer like Clocks, like his character isn't necessarily always dancing underneath. He's moving, right? Like traveling through space. There's a lot of like I said, with walk cycles or like yeah, right. And then he's using the stop motion effects to hit timings in the music,
Yes.
and that's another approach to dancing with it, right? Where what he's doing isn't like it's not groove driven, but it's musical timing driven. And I think a lot of that comes from like whether like the type of music you like to animate to, right? Stuff that's funkier or stuff that's more like electronic, and that's going to inform your approach. And I encourage everyone to like understand both right approaches. I think it's very valuable. But the idea of like whether or not your character is dancing or you're dancing using the stop motion effects to hit beats is kind of they're like the two biggest approaches I see in like differences in approach I see. You know? Yeah. But like
Continue.
oh sorry. Like I think a cool understand anyone can do to understand this, and I've done this a few times, is just take a video of yourself dancing, right? Or doing like like your baseline movement, like what a movement you think is interesting, and like don't bother animating, right? You don't even need music. Just like get something going, and then if you take it and put it into like a video player, and you just like play music, and then just hit like pause play, pause play, pause play, fast forward, slow, stop, pop, 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 and just watch yourself like because that is functionally what animation is. It's turning yourself into a character on a screen with like time control effects added, right? So you can actually learn a lot about yourself and your dance and how you can play with animated timings and animated movement by seeing yourself visualized on a screen like, oh, like that's me in stop motion and understanding that the mechanics of that. No, but that right, that's literally
You're what you're saying is completely correct, and it's something that it just opens the mind of I think everyone that will if they try what you're saying,
yeah.
it will open their mind, right?
now when I animate is the I picture like I am in the screen, right? And there's just someone there just pop, 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 like playing with the controls, and I'm like going back and forth, right? Like,
You can rewind it, pause it, you could slow mo it, you could do you can literally see yourself
yeah,
animated. How you're like, okay, can I reach that?
and like how to like freeze time and like actually like perfectly stop and like the itch and like oh no like the camera's bugging out,
Yes,
right? Like seeing yourself actually glitch
yes.
in video and being like, oh, so like take that, reverse engineer it, and put it onto yourself in real life.
Reverse engineer it.
Yeah,
Yes,
yeah,
yes. Nice. Signature wrote, animation provides a lot of freedom of interpretations for your character to move through the song and time in an illusionary way that dictates what the sounds of the music would look like if it was inside your body.
yeah. Also, shout out to Gizmo and OG Hurdle. It was
Yes.
a honor. It was a genuine pleasure seeing you guys get down at Unimate. I learned so much. Y'all are so sick, and yeah, like you guys have helped inform my animation approach so much. Like seriously, right? Just the idea that you can. Yeah, good to see you. Absolutely. No, incredible stuff. And yeah, just like understanding the illusion elements before it ever I ever worry about the dance, right? Just building that connection and that the narrative and the character quality.
Alex, can you share a little bit about the animation event in Chicago that you are hosting, correct?
Yeah, yeah. So my crew Shadow Puppets, it's our first animation event. It's called Devils in the Details, and we really wanted to fully explore animation. And so there's a top 16 bracket um with a couple things that are catered specifically to animation. So we have concept driven rounds. So we want people in the process of preparing for the battle to also explore just like new space and new ideas within animation. So there are concepts for each. The top 16 is character and like techniques functionally. It's one round of each, and just focusing on each one. And then after that, it gets into ideas of like we draw concepts from a hat. So there's animated grooves, levels in 360, fixed points, like patience, right? Like gravity driven illusions, things like that. So that's the bracket. We're really excited about that. It's gonna be really cool. And then we also, as a kind of shout out to the street performance and like mascotting roots of the style, like like that animation got started a lot in like like the talent shows and these like
Yeah. The mascots dressing up in the school play, the bands, the whole story. Yeah.
So we're doing a an invitational animation showcase competition. So how that's going to work is we're inviting high level animators out, obviously, to do. They get 5 minutes. Costumes are welcome, props are welcome. They get to choose their song. It's like a performance, and basically the crowd, everyone who is in observation in the crowd is going to get given like 5 Monopoly dollars functionally, and then at the end we're going to have everyone there with a hat on the ground in front of them, and you're going to vote like who would you if all these were street performers on the same street, who
Wow. You're having a street performer contest, pretty much.
kind of like everyone's going to do a showcase. That's September 20th and 21st in Chicago. And yeah, and then the workshops are the next day, and the workshops are really exciting because they're going to be co-taught. So there's going to be like a robotics workshop. So we're gonna have one of the judges is going to teach robotics, and then we're going to have an actual like programmer, like robotics, like hardware to software engineer, come in and talk about
That's
how
crazy.
like robotic position controls work. Same with stop motion. My stop motion animation coworker will be coming in and bringing in some puppets and
Yes, that's so dope.
like the softwares they use to animate. And yeah, so it's going to be a real focus on animation, like the source material and the roots, and trying to bring that experience to an animation event.
That is so dope,
Yeah,
man. If I will see if I can make it, like, just to even be in the room with engineers and actually stop motion animators. And just being in a room with dancers as well. That's so cool. The bridge. I love the bridging community. So I love that you're doing that. You're bridging two totally different communities that are, well, the dance community is watching the other community, but now the other community gets to see, oh wow, y'all are imitating the things we're making. So
It's funny, this was my second Unimate, you know, and it's so cool seeing this growing community and it's getting bigger and people are excited. And like Unimate, shout out to Yaya, was like it's the only space for animators in the US, really, right? Like it's the and we in Chicago, we've been like in the Midwest, we've been fostering new kind of like there's an animation community and we're kind of looking at it like it's big enough now that like I think we're ready to like bring in some like it's we've thrown popping battles and it's the same thing. We're trying to get like national talent here, and interfacing with our local community and showing like what our local community can do, but also like exposing them to like these high level animators and just having a good time and bringing the fun to Chicago, right? So
yeah,
oh let's go, yeah, Signature, you got to come through. It's going to be a good time. Yeah, the Midwest, we're doing it. We're out here. I think there's a thing about Midwest dancers is that we have a mentality of like kind of keep your head down
mm,
and train, and like people will see it when it's ready, and then like it's never actually ready. So getting like trying to break that and like to be like this is what we do. We're here. The Midwest animation scene is real and strong, and that we're excited to see everyone.
that is really exciting. That is awesome, man. My last question is, what would be the message you would like to tell the people watching, the people that will watch this later, this video, our discussion? What's a message you'd like to leave with them?
Love you and Gizmo there, and yeah, if you guys come out, let us know, and we'll talk about the showcase for sure. Like absolutely, that'd be an honor. But yeah, sorry, yeah, in terms of animation and robotics, like I think we're at this impasse. Like one thing I noticed at Unimate, there were so many new people, like so many people just now getting into animation and robotics, and like a lot of them knew what they were doing. That's really cool to see because for a long time people were like I'm an animator, but like let's see it, and they just like they tut, and which is like fine. They're like it's good tutting, but like the like there's a whole generation of people who know like are coming up now who are going to be who you can see just the potential, right?
Right, right.
How easy it is to find like inspiration, right? That can kind of make you not just like good, like technically stronger, but just like stand out, like to have a unique approach. Always there's I'm excited to see really high quality technical work always, but I'm also really excited to see someone who's doing something new. I'm like, whoa, what is that, right?
Mhm.
And magic of animation is people bringing to the table like, okay, yeah, like your mannequin's really good, but check out my hay baler. And it's like what, right? It's like Pokemon. People show up, you're like, what is that thing? You know, like I like the idea that that we as a community can be so like find this common ground, be so supportive of one another, but also like vary so intensely, right? And so yeah, like my message to everyone is just like do your homework, find your references the same way the OGs did. Find, the character that resonates with you and that you like and make it your own and figure out how to apply all these great techniques we have to expand this dance and create, something we've never seen before.
Wow.
Yeah.
Man, thank you so much, Alex, for coming on, sharing this information, and really giving examples as well. And I know for sure there's a lot to take from our interview, our this discussion, and I'm excited to see what people take from this as well and how they implement it into their robotics animation. And of course, this can apply to even other styles we didn't talk about. But yeah, thank you again, Alex. I appreciate that.
Yeah. Once again, thank you to, the OGs in the chat. Like you guys have made this dance what it is. I'm really grateful for animation and you guys are the thanks for that. So thank you guys. But yeah, and thank you, Jay, for doing all this like documentation. It's
Yeah, for sure. It's a pleasure, and yeah, I'm excited for people to just take the information, hear it, come across and be like, oh, what's this? And they're like, oh wow, look at all this information. But yeah, thanks again, Alex. Thanks everyone that was tuning in, And yeah, hopefully I'll catch you either in Chicago or you come to LA or somehow we will cross paths again. So maybe online. We'll just talk.
Yeah, for sure.
Anyway, take care, man.
Thank you, Jay. Have a good one.